Okay. And okay, so we are back again. Let's try to close this one. Okay. Okay, we are back. Is connection working here? Okay, you're checking out. I am resharing this session to LinkedIn. How do you pronounce LinkedIn? That's one of the words that I never speak about. Okay. Okay. Okay, let's continue. So
give you this little challenge. All right, we went a bit on a tangent, so let's bring it back. Can I do things like this? Is 1 greater than 2? Or you know what, let's do less than 2, and less than 3, and less than 4. Will this work? Well, of course it will. It's just an expression, right, that we're evaluating. And all of this is true, but as soon as I change, and something is false, it's going to short circuit, which we learned about previously, and return false. All right, so we know the greater than, equal to, less than sign. We also have greater than or equal to.
So that when something is false, it's not going to continue.
1, I get true, because it's saying, hey, is this greater than?
To evaluate something else,
I can also
it
do
doesn't matter.
Or equal to 0. And here, I get false, because 0 or 1 is not greater or equal to 0. But if I do 0 here, I'll get true. Here's another one. What if I do this? Exclamation mark equal. This means in Python not equal to. If I run this, I get false. And this is a little tricky. What it's saying is, hey, is this not equal to this? So it's the opposite of doing equals. If these two things don't equal, it's going to say true. So if I do 1 here, I'll get true, because these two things do not equal. So we've learned greater to or less than, greater to, equals or greater or equal to. We've learned about less than or equal to. We've learned about not equal to, but we've also learned about and or. And finally, there's one more I want to teach you, and it's the not keyword. I know, it's a little much, but it's not as hard as you think. Not is, well, the opposite. So if I do here, not true, what do I get? I get false. And you see that not is also a function. So it's a keyword, but also a function that we can use. If I do not false, again, I just get the opposite.
With the brackets.
If I do not 1 equals to 1, what will I get here? I get false, because this expression evaluates to true, and then not just does the opposite. So let's take a break here and work on a little bit of an exercise to make sure that we understand this.
Okay. Exercise. I should do this one.
Welcome back. Let's do a fun little exercise. We just got hired by a gaming company, and we're creating this wizard game. And this wizard game has the is magician in the user's profile, and for now we'll just set it to false. We also have is expert. And whether this user is an expert at this game, we'll leave it at true for now. And then let's do this here. I want you to check if magician and expert. And if that's the case, if true, then I want you to print you are a master magician. And also I want you to check if magician, but not expert. If that's the case, I want to just print at least you're getting there. And then finally, let's do a check that says if you're not a magician, I want you to say, well, you need magic powers. Now, I want you to use what you've learned about logical operators to create this conditional logic. You can pause the video if you want and try it yourself in a REPL. Otherwise, I'm going to keep going with an answer.
Okay. I'm going to pause that one. Okay. Let's try to open Replit. I have a new link there. That was for writer. Okay. So this is my Replit. Failed to connect. Oh, come on. I will eventually move into local Python, because right now I'm using this website to code the exercises and the examples. What's going on? Okay, let's try to... Okay, here. And I have the hello world. Put in REPL. How do you pronounce this? REPL? Failed to connect. Now why? I don't think I have Python. Yeah, I don't have Python installed. Yeah, I'm going to hang out a little bit here, or yeah, I don't know what happened to REPL. Maybe if I try to build, to create a new repository here. Okay, let's create Python. Okay, let's call this, let's copy this. Let's call it like that. I guess I'm not going to be able to use special characters here. Okay. Damn it, failed to connect again. Yeah, I don't know what's going on. Can I, yeah, I'm going to complain on the internet. Okay. Let's complain on the internet. Is this the REPL one? Which one is the REPL? No idea. No, it's not working. Well, I'm not going to waste any more time. Let's just...
You should be able to solve this fairly easily if you've been following the videos and exercises so far. So let's start with...
Well, maybe I can just type it on Visual Studio Code, although I'm not going to be running anything. It doesn't really matter. Let's save it as a disposable file, who knows. Yeah, why not here? Yeah. Yeah. Show recommendations. Python by Microsoft. Okay. Okay. It adds I don't have support unless I install this. Yeah. Well. Bye. Okay. Okay, it's already on? Yeah. Exercise Python. So, do I still remember the syntax for the if statement? Okay, I do have two variables. Is magician false? Is expert true? Okay, let's do that first. I'm not used to this keyboard at all. Okay. Yes. Okay, now I had to do check if magician and expert. You are a master magician. Okay, guess if is magician and is expert, semicolon, enter, and I do something here. Well, I can just print it basically. What do I need to print? You are a master magician. Okay. Is something like this. There we go. Maybe there. That looks way better, in my opinion. Maybe a little bit more. Okay. What's the next one? Check if magician but not expert. At least you are getting there. Okay. In here, elif, and I guess check if magician but not expert. Okay. elif and not is expert. Semicolon, I guess. Okay. And the last one is, if you are not a magician, you need magic powers. Okay. Wait, if you are not a magician, you need magic powers. Okay. Well, this is not an else, actually. This will be another elif. Oh, wait. Not. And I guess that's it. I'm not going to be able to run this here. At least I should be able to watch the solution without guilt. That's something.
First one, where we say you are a master magician. So I'm going to say if is expert and is magician.
Wait. What? I'm losing... my video just died, but in the stream it is okay. What the hell? Am I losing connection here or something? What's going on? Okay, never mind.
I am going to print you are a master magician. So I'm going to copy that and say print you are a master magician. Nothing too crazy here. And then next one, I'm going to say if, or I could even say elif if I want. And again, this is something that you can decide what you prefer. I usually like using elif if it's part of the same concept as the first one. In this case, yeah, we're still trying to figure out what type of user it is. So we'll use elif and we'll say elif. We want to check if it's a magician. So that is magician. So we're going to check if that's true. But we also want to check if, well, not an expert. Now, how do we do this? I mean, we could use short circuiting and say is expert. And even if this is false, we can get true here because is magician, short circuit, and print this part.
Yeah. Huh?
Because the interesting here is that this code block is never going to run if both of these are true, because in the first if block,
oh, well, you're right,
as soon as
actually.
this is true, we're going to completely ignore the elif. So we could do that. But this is a little bit hard to read because I really have to think about it. If I come back to the code or somebody else looks at my code, it's not clear that, unless I comment that I'm checking magician but not expert. Because
technically, this logic isn't complete with using OR. Because as long as either of these two variables are true, the code will run. Yeah, that's another thing.
Will never run if is magician is false, then that's what they're checking.
So basically, it's not working as he is explaining it. But doesn't matter. You need to use and not.
Right? It makes a lot more sense. Hey, if this person is an expert and magician, do this. Otherwise, if this person is magician and not an expert, then print this. That reads pretty nicely. And yes, you can do this because remember, not is simply checking and inverting whatever the Boolean expression is. So this still evaluates to a Boolean that AND can check. All right, let's finish the final one. If you're not a magician, you need magic powers. So how do we check here? Well, we can do another if and say not is magician. And if I run it like this and say print, and we'll just copy here.
Did I type the not? Oh, yeah, it is here. Okay.
You need magic powers. And let's remove the comments for now, just so we can see the blocks of code. And we're going to test our program. Hopefully we coded it properly. Hopefully there's no bugs, but let's have a look. If I run this, you need magic powers. Why is that? Well, if magician is false, none of these are going to work. What if I change this to true and I click run? Right. I am a master magician because I'm an expert as well as a magician. What if I turn this to false and I click run? Hey, at least you're getting there. I'm a magician, but I'm not an expert yet. I still need to improve my gameplay. Now, you may have gotten a different answer than me, and there's many ways to do this, right? You could have used an else statement. You could have used or. Conditional logic is all about writing code that makes sense, not only to you, but for other people reading your code. The idea is not to be extremely clever or really worry about short circuit.
Yeah.
Yes, it can be more performant, but a machine is so powerful that just a tiny bit of optimization there is usually not worth it when you're losing perhaps readability. So you want to make sure that your code reads like English. And this is a topic that, frankly, a lot of beginner programmers have a hard time understanding, where they try to be as clever as possible, write as little code as possible in the shortest possible lines, when instead you want to focus on readability, because a code that is easy to understand is a sign of a good developer. And I hope looking at this, you're thinking, yeah, this is pretty easy. I mean, this all makes sense. But this is not the only way. Maybe my version of what reads well is different than yours. The idea is to each of us try our best to make our code simple and nice. And in programming, there is no one right answer. There are many ways to solve a problem, but the key is to solve it in a simple manner that is readable.
Yeah.
Have fun, and I'll see you in the next one.
I agree with making the code
All right, in this
not
video, I'm gonna
too
try-
clever.
I want you to look at these expressions where I'm checking for equality, right? I'm saying, hey, does true equal 1? Does empty string equal 1? Do two arrays equal that are empty equal, well, each other? Now, pause the video here and try to guess what the outcomes of this are going to be.
Okay, on the first one, true equals to 1, since either 0 is going to default to false, any other number other than 0 is going to return true. So this is true. The second one, the empty string is going to be translated to false. And the 1 is going to be translated to true. So false equals to true. Now, so this is going to evaluate to false. I will guess that an empty array or an empty list is going to be equals to false. I don't know, not sure, because this is a more complex object. 1 is going to default to true, so I guess this is false. All of line number 3 is going to be false. Then is equals to 10 decimal. I guess it's going to be true because they are the same number. However, they are different data types. And I guess an empty string is false and another empty string is false. Are those equal among each other? I will say yes. So this evaluation is true in the end. So it's going to be true, false, false, true, and true. Okay.
Ready? By the way, if you get 100% on this, well, good for you, because if this was my first time learning Python, I wouldn't get this. Let's go. Is that why you...
Okay, let's see. It's true, false, false, true, and true. Yeah.
expected? True. Evaluated. So true equals 1, evaluated to true. An empty string equals to 1, evaluated to false. That makes sense because they definitely don't equal each other, right? An empty array doesn't equal to 1. And a 10 equals 10.0. And then both arrays that are empty equal to true. Now, the reason I'm showing you here is that the double equals checks for equality, or equality of value. That is, if, for example, the first one, true equals to 1, there's two different types. One's an integer, one's a boolean. It will convert them into the same type. In this case, this will be converted like this to a boolean value. And if you remember, 1 is truthy. So this will evaluate to true, which is why we get true. What about the other one? Well, an empty string is falsely, so it evaluates to false, and false doesn't equal true, right? Because we're checking for equality here. So one of these gets converted to the other's type. What about an empty array? Again, an empty array is actually falsy. So that's not going to equal 1. A 10 equals to a float of 10.0. That gets converted to an integer or a float, and they're going to equal each other. And that's an expected behavior. And then an empty array, well, equals an empty array. If I add in this array 1, 2, 3, 1,
yeah, they are not.
and I click run, I get an invalid syntax. Oh, because I have this here. Let's run that again. I get true.
True.
That makes sense. Let's change this to 1 and see what happens. If I click run, all right,
It still remains as false. Wait, what? 1. Oh, yeah, because, wait, if that's a string or a character, that should be true, isn't it? Why is false?
this does get a little tricky, right? Like, should this have a value?
Yeah, that's although the character itself is not 1, it may be whatever it may be. A non-empty string will give me true, isn't it?
Evaluated to true, but no, we get false. So this doesn't get converted in type versus what we had here. Now, don't get confused by this because this would be bad code. If you're checking something like this, well, obviously you should be checking 2 types, 2 of the same types together. Ideally, when you use comparison operators or logical operators like this, you're comparing 2 types and you're not letting Python do this type conversion, and hopefully Python figures it out for us. But I hope the double equality makes sense because there's another check that we can do, which is. And is, well, is a keyword in Python. What happens if we change all these equal signs to is? Do you think there would be a difference? Let's have a look.
I don't know.
If I click run, I get false.
They are
for
false.
So what's the difference here? Equals checks for the equality in value, such as 1, 2, 3. Well, that has the same value as 1, 2, 3 in a list. Is actually checks if the location in memory where this value is stored is the same. Let's go through that. So true, is that 1? No, true is not 1. True is, well, only true, right? That will be true. What about string 1? Is that 1? No, I mean, for 1 to be a string, that needs to be 1, right?
True,
because the 1 string isn't only in one place in memory. It's literally the exact same thing. What about this list? As a matter of fact, let's do is array, empty array, is that, or is this list a list? Well, if we run this, I still get false.
False, because that's a complex
and this
object.
And also, every time I create a list,
that's
it's
a list
added in memory somewhere. So this is in a location in memory. But whenever I create a new list,
that's a new one. That's a different one.
These are 2 completely different lists that live in different locations in memory. So it's going to check, hey, is this in the same memory space, same bookshelf as that one? Nope, that's not it. But why does this work for things like numbers and strings? And that's because underneath the hood, these are types that are very simple that are in memory, but in one
those
location.
are primitives,
versus
I guess.
like a list, even though this
that's
might
a
be the same
complex
list with the same
object.
items. Because this is a data structure, every time we create it, it's created in a new location.
A new one.
So that even if we have a variable A that contains this list, and by the way, this will be the same for all our data structures like dictionaries, sets, tuples. If I do B equals, and I check A, is that
it's going to be false?
Nope, they're created in a different memory space. So this, where A points, is in a different
place than B equals A
equals to B, I get true because this double equality checks only the value.
Oh, the values.
Now, this is a bit of a hard topic. So you might have to watch this video a couple times. You might have to practice this a few times yourself. But just keep in mind the difference between is and double equals. Is tends to be a little stricter. You're checking for the exact thing that you're looking for versus equality, which checks the value. All right, that was a doozy. I'll see you in the next video. Bye-bye. Let's talk about loops. We've talked about conditional operators, logical operators. But loops gives us a whole new power when it comes to our machines. The concept of loops or looping in programming is really, really powerful. We saw that with logical operators and conditional logic, we're able to skip lines in our program so that we don't always go 1, 2, 3, 4, 5, 6, so on and so forth. But loops do a really interesting thing. It allows us to run lines of code over and over and over. That's really powerful because that means we can run things thousands of times, millions of times. And this is where machines excel. Machines excel at doing small tasks over and over really, really fast, way better than humans. So loops are one of the most powerful features of programming languages. So how do we create one? Well, it's as simple as using what we call for, or in Python, we call them for loops. With this keyword for, we're able to say for, let's say item in 0 to mastery, do something. So they're kind of like conditional operators. Instead of if, we have for, but then we have this thing, right? Where we have item, which, what is that? We don't really know. Well, this is a variable that we create. We can name it whatever we want. We can say I, we can say teddy bears, whatever we want. This is a variable. And a variable is created here for each item after the in. So it's saying, hey, for every item in 0 to mastery, do something. And we've seen this in
print
before.
Maybe.
And we'll dig deep into this later, but we call this an iterable. An iterable is something that is able to get looped over. So an iterable allows us to use this notation of a for something in an iterable to iterate over each item. In our case, if I print item here and I click run, look at that. It prints each item
the
in
string.
the iterable, which is the string 0 to mastery. So every letter, it goes into every bookshelf in our machine's memory. And
strings themselves are collections.
Now this works with strings, but we can also use lists like 1, 2, 3, 4, 5 that we've seen before. If I click run, again, this is an iterable. We're able to iterate over it and it grabs each item in the list. Let's do a set. Could we do this with a set? Well, if I click run,
I guess
that works
pretty
as well.
much the
What about
same
a
thing.
tuple? Let's do it with a tuple. If I click run, that works as well. That's amazing. What about a dictionary? Well, we'll get to dictionaries in a bit. So for loops allow us to iterate over anything that has a collection of items. So that in this case, we're looping 1, 2, 3, 4, 5 times. And you can see over here that we have the colon and then the indentation to tell Python, hey, whatever comes here, I can print item again, I can print item again. I can do it as many times as possible. As long as I have indentation, it's going to keep printing
the same element.
As soon as I open up here, and
that's another thing.
Well, I only do that once because it's not in the loop. So our program first runs this for 1, so it's going to print 1 3 times, then 2, then 3, then 4, then 5, and then only finally then
that's a
goes to print.
tuple.
You see how we're looping over and over and over. Now, what happens if I try and print item here? And I click run?
It's not going to work.
Did you see that? Item
Oh no.
At the very end here, I don't know if you can notice it, but you see that there's 4 5s. We've printed
Yeah.
1, 2, 3, 4, each 3 times, but 5 gets printed.
The last one,
because this last
because it's
print
outside
at the very
the
end
loop.
is, well, 5. Because by the time the loop ends, the value of item is actually 5. Let me ask you this. Can I do something like for, let's say, x, in another list that contains strings A, B, and C? Can I do something like this? Absolutely. I can nest things in Python. And as a matter of fact, when we do conditionals in Python, like if statements, we can always nest those as well. Because in Python, it's always the indentation, right? So I can say print here item, and then also print, and you know what? Let's print them one next to the other. So I'm going to say print item and print x. If I click run, you see that we're printing 1 and A, 1 and B, 1 and C. Because item, we run line 1, so item is currently 1. So we're going to go to the next line, line 2, and we're going to say, we're going to loop over this iterable, and we're going to say this is x. So this is going to be 1, this is going to be A. And then Python comes back to line 2 because we're still in this loop. And we're going to say, hey, what's x now? Well, we're done with A, so let's go to B. So it's going to run B, and then C. And only once this is done does it go back out and now starts with 2, which is right here, 2A, 2B, 2C. So you can have nested loops over and over and over as well.
Yeah, nested.
Right. So these are loops. And right now, maybe it's not completely obvious why these may be useful. But before we get into that, I want to talk about this idea of iterable in the next video.
Now that he mentions it,
Welcome back.
it's true. It's not really clear in which way should we be using a nested for loop. So it's actually really useful because you might either have the need to do something that has subdivisions, for example, an object, or maybe, you know what, I need you to print the names of the students inside every classroom. And you may like to print, let's say, the name of the classroom and then the name of the student and so forth. So basically, you might need to loop through the classrooms and then iterate over the students for each classroom. And whenever you are finished iterating over a single classroom, you need to move to the next classroom and iterate over that list of students all over again. So maybe I'm not being clear myself, but who knows?
I kept mentioning this key term, iterable. But what does it really mean? Iterable, you're going to hear that over and over in Python programming and other programming languages as well. And as we discussed a little bit in the previous video, iterable simply means it is an object or a collection that can be iterated over. So again, an iterable can be a list, can be a dictionary, can be a tuple, can be a set. It's a collection of items. We also saw that a string could be iterable. Now, these things are iterable. Why? Because they can be iterated. That is, iterated means we can go one by one to check each item in the collection. And you're going to hear this over and over when talking to Python programmers. So you want to make sure that you have that vocabulary. You're iterating over something. You're looping over something. So iterable is the noun, and iterated or iterate is the action of iterating over an iterable. I know, it's a little confusing. Now, many objects in Python, like I said, are iterable. But there's a few special ones that we haven't covered yet. Specifically, dictionary. We saw how lists, tuples, sets, and strings can be iterated. But what about an object? Let's say we have an object here, and this object will be users. And users, or user, will have a name of Gollum. We'll have age of 5006. Gollum's pretty old. And then we'll say, can swim. Gollum, let's say, cannot swim. False. What if we use this object right here for item in user, and we print right here the item? What do you think will happen? Let's run this. Well, I got an error because I forgot a semicolon here. And we don't want equals, we want semicolon. And then obviously this needs to be a string as well. Now, if I go to run here, look at that. I get name, age, and can swim. So I've printed the keys of the dictionary. Now, this dictionary, we have the keys. That's great, but what if I wanted actually the values? Is there a way to do this? Well, dictionaries have 3 methods that are really, really useful when we want to loop over their keys and values. The first one is items. And with items, when I do this and I click run, you'll see that I get the key value pair in a tuple. And this is a very common pattern that you'll see a lot. Another one that we have is the values. And guess what that does? That gives us the values of the dictionary. And we saw that user, just leaving it blank, gives us the keys. But we have a method that is more descriptive and allows us to show exactly what we want to do, which is keys. And if we run this, you'll see that I'm able to iterate over the keys. And these 3 methods are very common, and you're going to use them a lot in your programming career. So make sure you take note of them. Items, values, and keys. It allows us to iterate over dictionaries. But another interesting thing they can do, and another common pattern when iterating over dictionaries, is what if you want to print, for example, separately, the items, name, and column. So right now we're returning a tuple. And we saw that we can do tuple unpacking, right? I can say key value equals item, and then just print key value. If I run this, you see that I'm able to print these. But there's actually a shorthand way of being able to do this. In here, in the for loop, I can say
okay.
key value and just completely avoid this entire line.
Okay.
And if I run this, there you go. It still works. And this, again, is a very common pattern, where if you're collecting the items of a dictionary, you can separate them into key and value, or you might even see shorthand K and B. Again, these can be any variables that you want. You can name them whatever helps your code be more readable. By the way, just for fun, let's say in the last line here, I want to iterate over the number 50. What do you think will happen then if I click run? Sorry, name error. Name key. Oh, I got an error here because I haven't changed these. So
Yeah.
that's not the error I was expecting. The error I was expecting was this. Type error. Int object is
It's not iterable.
Now, this error should make sense now because I've said it over and over. Why is it not iterable? Well, because it's not an object that can be iterated over. It's not a collection of items. Because we learned that in Python, these are iterable. I'll see you in the next video. Bye-bye.
Okay. Sticky counter.
Welcome back. Let's try a simple exercise. I want you to build a simple counter. And this counter is going to count the items in our list. What does that mean? Well, let's say I have a list. And this is a reserved word. Remember, it's an actual word in Python. So let's name it my list as a variable. And this list has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What I want you to do is using looping to loop over this iterable list and sum up the total of the list. Pause the video if you need to. Otherwise, let's see how we can do that. What I'll do is create a counter variable that will equal to 0 to start off with. And then I'll say for item in my list, I'm going to counter equals counter plus item. And then at the end, I'm going to print counter. Let's see if this works. I'm going to hit run, and I get 55, which, if my quick math is right, should be correct. Now, when doing this exercise, you may have gotten tripped up a bit. So let's think about this. Some of you may have made an error where you did the print here. But if you did the print here, you remember that it's going to get looped over. It's part of this code block because of the indentation, and it's going to print as many times as there are items. So you have to make sure that the indentation is like this so that you get the total. The other thing that you notice is that in order for you to keep a counter or a total of all these items, you had to make sure that you had a variable outside of the loop because the loop runs the code over and over. And you needed something on the outside that doesn't change. Because if you moved the counter to 0 here, well,
it's going to restart.
Counter will be reset to 0. So that by the time we get to 10, counter would be 0. So you get 0 plus 10, which equals 10. And then you get, well, 10. So you have to be careful here that the indentation is an indication of us looping. And when you loop something and you want to keep a tally or total of something, that you have these issues of making sure that what you want to loop over is inside of this code block. But what you don't want to, if you want to have some sort of information that's outside of this loop, that you keep it like this. If you weren't tricked by this question, good job. If you were, don't worry. It's all part of learning. I'll see you in the next one. Bye-bye.
Okay, let's check out range.
When looping in Python, one of the most common tools is this range function that we get out of the box with Python. And you see here that range, well, is a range object, a special type of object in Python that returns an object that produces a sequence of integers from start to stop.
Interesting.
Let's explore that a little bit more. If I print here a range, and I say range 100, and I click run, I get range of
From 0 to 100.
So it looks like a tuple, but it's not. It's a range object. It's a special type of object. And range, you can give it like this, which gives you a default of 0 to whatever you give it, which is 100. Or you can just simply type 0, 100. And if I click run, it's the same thing. But where range becomes really useful, and you'll see this in 99% of cases in Python, is in for loops. You see, besides tuples and lists and sets and dictionaries and strings, you can iterate over a range. So for example, if I do for I in range, and let's just say item, or in our case, let's just do number in range. And in here, I do print.
It's an iterable object.
You'll see that I'll get numbers 1 to 100. And why is this useful? Well, using range, I was able to loop 100 times.
0
you can
to
see all the way
100.
till 99 because our count starts at 0.
0 to 99.
As many times as I want, so I can tell the loop. Maybe we want to loop a certain number of times. Maybe we want to loop 10 times, where I can tell the loop how many times to run. It's extremely useful. Maybe here we're performing some action where it says, I don't know, email list. So we want to send 10 emails to an email list, for example. Well, again, I can just click run, and I sent that email, well, a bunch of times, 10 times. Another neat trick is that, well, you might not even need number.
Wait, what was that? I will actually show you how to send emails with Python in this course. Oh, yeah, I know.
Another neat trick is that, well, you might not even need number, right? We're not really using it in our code. And often what you'll find in Python programs is if a programmer doesn't need this variable, you just do an underscore. And this is just a variable. I mean, you could use it like this, and you'll still get these numbers, but it just indicates to other people that, hey, I don't really care what this variable is. I'm just trying to use range so that we can loop over things, let's say 10 times.
Okay.
Now, range also comes with a third parameter. And what that is a step over. So if I do 2, and by the way, default is 1.
Oh, in the steps is 2.
It jumps from 0 to 10 by 2, which is very, very handy. So what is range? Well, range creates a special kind of object that we can iterate over. Okay, what if I do minus, right here, what if I do minus 1? Well, if I run this,
oh yeah, from the end
because,
to the start.
Let me show you why.
Yeah.
If I change this to 0 and 10,
the reverse, okay. Then,
it's going to go in the opposite direction. But if I did just 10 and 0,
it's not going to work.
If we want to do something in reverse, we just have to make sure that we add that minus 1. Or if we want to step back, twice, then we click run. So you have a lot of options to play with the range. You can do ascending, descending. One final thing. Another place that you might see ranges, and like I said, most of the time they're in for loops, but you can also do something interesting like, let's say, a range of 10. And then if we wrap this in a list, remember a list function allows us to convert something to a list. If I run this, did you see that? Let's simplify this so that this range is going to just be 2. If I click run, you see that I loop 2 times. And in here, I'm going to print, first of all, I'm going to create a range, an iterable object that has 10 items. And then I'm going to convert that into a list. So you can see here, 0 to 9 into a list. So this is a quick way to create a list that, well, has integers. A neat trick that you'll definitely use along your programmer journey. I'll see you in the next one. Bye-bye.
Enumerate. Okay.
Let me show you another useful function that we'll use just like range. Mind you, it's not as common as range. Range, you'll see it a lot in Python code. But this other one is still very useful. And it's called enumerate. Now, what does it do? Let's have a look. I can do a for loop. And I'll say for. And we'll say character in enumerate. And then enumerate, we wrap around something that, well, we want to enumerate. So let's see what that means. It returns an enumerate object. So iterable must be another object that supports iteration. So we have to give it something that enumerate can iterate over. So this time around, let's just do a string that says hello. Now, enumerate is special because what it's going to give us is it's going to take an iterable object and gives you an index counter and the item of that index. What do I mean by that? Well, you can actually say I, comma, character. So we're unpacking this and we're saying, hey, print I and character. If I click run,
0h, yeah.
I get
hello, I get it.
Iterated over. Again, if we don't have enumerate, then we would have just gotten
it gets the index.
But also, because we use enumerate,
and the value.
I, or index of each item and where it is in the index. So that if I had a list here, let's say 1, 2, 3, again, I'm able to use and access the index number of the item as well.
Yeah.
What if we had a tuple?
The same thing.
Again, we get the index number. So enumerate is very useful if you need the index counter of the item that you're looping through. So let's do a little exercise. Let's say that we want to create a script that enumerates a list of numbers 1 through 10. So we'll use range to create that. I'm going to say list, and then I'm going to say range. I know there's a lot of functions here. Range, that is 100 actually. Let's do that. And I want to be told what the index of the number 50 is. So pause the video if you need to do that. Now, here, I want it so that, let me make this a little bit bigger. I want it so that we only print the index of, let's say, the value 50. I want to know where 50 is in the list. Now, again, this is a simple example, so you can probably already guess what the answer is. But how would you code this so that only in here we get the index of 50? Or it says the index of 50 is pause the video if you want to give it a go. Otherwise, let's try this.
Maybe with a ternary operator.
Conditional, and says if character is equal to 50, then I'm going to print index, or I'm going to do an f string, and I'll say that the index of 50 is, and then I'll add the index in here. So that if I run,
there we go.
I get index of 50 is 50. And just to confirm, if, for example, I just print here, and let's say print I and character, I click run, we see that, yep, we have the indexes the same as the numbers. Again, not too difficult of a question, but you see here that we're able to extract this information. Again, not as useful as range, but you will see it occasionally in code, so I wanted to make sure that you're not surprised by it. As you can see, it's not that difficult.
While loops, okay.
Well, up until now, we've learned that with looping, we can use for. But there's actually another way for us to loop, and it's called, instead of a for loop, a while loop. And while loop is a little different in that we say while a condition is happening, do something. So you can see that there's a bit of a difference here. For example, I can say that while 0 is less than 50, do something. Or I can say, for example, I equals to 0, and I'm going to say while I is less than 50, print I. Now, if I ran this program, what do you think will happen?
It's going to loop
if I click run
infinitely because it doesn't change.
I don't know if you can tell, but I'm scrolling right now through all of this. It's looping, 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 looping. And you see that the program is still running. As a matter of fact, I have to stop it because what it was doing is it was looping and looping and looping because if we look at the code, well, 0 is always going to be less than 50. So what happened was while this was true, we printed I. And then the Python interpreter went back to line 2 and says, hey, is 0 still less than 50? Yep, okay, next line, print. Hey, is 0 still less than 50? Yep, okay, next line, print. And it kept
the next one.
going. Now, this is what we call an infinite loop. That is, the program doesn't know when to stop. I mean, we're telling it to just keep going forever, for eternity. And I have some safeguards in place here, but if you did this in code, you'd get this infinite loop until your program crashes. If you actually ran this code, well, it's going to keep running until the machine just doesn't have enough power anymore, enough resources to keep doing this over and over. Everything has limits, right? So with a while loop, we have to be really careful. This infinite loop can be very dangerous. So how can we solve this? We have this idea of a break statement. And break is, well, just another keyword in Python. And as you may have guessed, if I click run, look at that, it only runs once. As soon as Python sees break, it's going to say, all right, break out of the while loop. So it's going to go to line 5, and it's going to say, got nothing there, program's done. I'm going to exit out of the program. But okay, what if I want this to be looped 50 times? How can we solve that issue? Think about it. Well, we can just simply say I equals I plus 1. And then make sure that we change this to
or I.
Now what's going to happen
Plus
if I click
equals
run?
I.
We stop. Well, 49. We've done it 50 times. We've looped through it 50 times because we kept incrementing I over and over. So that I, each time we came back to the loop, was incremented by 1. Now, a shorthand for this, we've seen it before, is to do plus equals 1. So that if I run,
the same thing.
So we're also able to break out of the while loop as long as we're able to turn a condition into false. So you'll see this a lot as well. So to jump out of a while loop, you can either turn the condition false, or you can break out of the while loop. Now, another interesting thing that we can do with a while loop is we can have else blocks. And here, we can say print done with all the work. If I click run here, at the very end, look at that, done with all the work. And this should read like English, right? While I is less than 50, keep looping through here. And as soon as we get to the last part, where
the while has an else.
Longer less than 50, Python interpreter is going to say, all right, I don't care about anything under there. Let's go to the next line. And I get otherwise. So in this case, we don't have anything else happening. We can print with all the work. But you're probably asking yourself, hold on, can't I just not do this and just make sure my indentation is at the end?
It's at the end.
That works, right? Why would I ever want to write else? Well, else is a special case here. There is one thing that is useful. That is, if we added for example, a break statement here, and I click run, you'll see that the else statement does not print. And that is because the else block will only execute if there isn't a break. That is, if the while condition turns to false, then it's going to keep going and do the else.
Oh,
if
interesting.
there is a break, it's going to break out of this whole thing and go to the 8th line. So a little gotcha here, that you won't see else too often next to while, but there is that special case where else is used when you want to make sure that this will be executed only if there isn't a break statement. Only if the loop is finished doing whatever it's doing without the break statement. Let's take a break and explore while loops a little bit more.
Okay.
So when should you use a while loop and when should you use a for loop? And it really depends on the problem you're trying to solve. For example, in a for loop, I could do for item in, let's say, a list, 1, 2, 3. And just looking at this code, you know right away that it's going to be looped over 3 times, right? And I could say here, print item. But you can do this in a while loop as well. I can say I equals to 0, and then while I is less than, let's say, the length of the list, that is 1, 2, 3. Well, in that case, I want you to print I, or the item, and then increment I by 1. If I run this, I see that, well, technically here we're incrementing the I, which is the value, but let's say we had a list up here. So my list, and this list will be 1, 2, 3. Well, my list can be iterated with a for loop, or can be iterated with a while loop, and we simply say my list at index of I. And if I run this, I get the same result.
Like similar to a
while
the
loops
for
are very flexible. We can do a lot because we have this conditional statement. We can loop more than 3 times if we really wanted to. So in that case, while loops are more powerful, but for loops are simpler, right? Like this code is really nicely and really well. It makes sense. We just want to loop over something that we don't know how many times we want to loop over 3 times. With a while loop, we have to create this variable, and we have to make sure we remember to increment variables so we don't get an infinite loop. So with a while loop, you need to make sure we remember to halt the loop at some point. So my rule is usually this. For simple loops or iterating over iterable objects, for loops are great. But let's say you're not sure how many times you want to loop over something. You're not really sure how long it's going to take for looping. So you want to say, while something is true, just keep looping. For example, let's say we're trying to go through an email list that we've collected on a website. And for each email list, we want to send an email. Well, while the list is still there, let's just keep sending emails. There are many, many cases. But one of the most useful ways to use the while loop is like this. Is to say, while true, do something. And make sure that at the end, we break.
Oh, okay.
Hold on. What's happening here? I'm saying, while true, wouldn't that create an infinite loop? I mean, true is always going to be true.
Not really, because of the break
Again,
statement.
we have a break statement here. So at the end, after we run line 3, it's going to break. But
then
now
why?
Like input here. And if you remember, an input is going to ask us for a prompt to enter something. So I can say, hey, input, say something. And if I click run, it's going to say, hey, say something. You know what? Let's add semicolon here or colon here, and let's try that again. And look at that. It's saying, say something. I'm on line 3 right now. So I'm going to say, hi. And did you see that? We just broke out of the loop.
You broke out of the loop.
Even though this was true, as soon as we got to line 4, I was done. But what if I remove this? And I click run.
It's going to keep asking over and over again.
And it asks me again, hi. Hi. I'm telling hi. And it keeps asking me. And we have an infinite loop. But the interesting thing here is that we can use conditional logic, right? What if we said response here and collect whatever the response is and say if response is equal to, let's say, by, then I'm going to break. So that if I run this again, I say,
oh,
keeps asking.
I get it.
You know what? I'm getting annoyed with you, machine. I'm going to say, it's going to exit it out for me. How cool is that? So loops are extremely useful for tasks like this, where looping can happen for a long time. You don't know how many times it's going to happen. But this is something that you're just going to have to
the user
eventually,
needs to
and I promise you
decide.
this happens where you'll figure
or
out when to use while, when to use
right
for.
answer.
At the end of the day, use whatever solves your problem. I'll see you in the next one. Bye-bye.
Break, continue, pass.
Welcome back. Now, up until now, we saw the break keyword that we can use to break out of a loop. And you see here that we're able to loop with a for loop, but with a while loop, as soon as we break, we're done. We've just, well, broken out of the loop.
I'm going to pause it here. I'm getting very sleepy because I just ate. So I'm going to pause it right here. I'm going to sleep a little bit, maybe 2 hours, maybe 1 hour, and then come back and continue because I'm getting very, very sleepy right now. And I am afraid that I'm going to forget whatever I'm watching here. I guess that the continue works just the same as in Java and JavaScript, where basically you break out of a single iteration of the loop instead of breaking out of the entire loop sequence, which means that, okay, break, as soon as you execute break, you're going to leave the loop entirely. What happens if I want to just, you know what? I want to continue looping, but on this iteration, I want to just get out of this particular iteration, move into the next item, and basically continue. That's what continue is used for in JavaScript, I believe in C++, C Sharp, and Java. Well, I'm going to take a break. I'm going to get some sleep, and I'm going to be back.